even though we have powerful computers, only some mathematical things can be explored numerically. There's something called the combinatoric explosion. If you want us to study, for example, Zermani's theorem, you want to study all possible subsets of the numbers 1 to 1,000. There's only 1,000 numbers. How bad could it be? It turns out the number of different subsets of 1 to 1,000 is 2 to the power 1,000, which is way bigger than any computer can currently can enumerate. In fact, any computer ever will ever enumerate. So you have to be. There are certain math problems that very quickly become just intractable to attack by direct brute force computation. Chess is another famous example. The number of chess positions we can't get a computer to fully explore. But now we have AI. We have tools to explore this space, not with 100% guarantees of success, but with experiment. So like we can empirically solve chess now. For example, we have very, very good AIs that can, they don't explore every single position in the game tree, but they have found some very good approximation. And people are using actually these chess engines to do experimental chess. They're revisiting old chess theories about when you this type of opening, this is a good type of move, this is not, and they can use these chess engines to actually refine, in some cases overturn conventional wisdom about chess. And I do hope that that mathematics will have a larger experimental component in the future, perhaps powered by AI.
We'll, of course, talk about that. But in the case of chess, and there's a similar thing in mathematics, I don't believe it's providing a kind of formal explanation of the different positions.
No.
It's just saying which position is better or not, and that you can intuit as a human being. And then from that, we humans can construct
Yes.
a theory of the matter.